Hello dear students, welcome to Nuclear Physics 1 course lecture number 2. I'm Dr. Parvez Ahmed. In this lectures, we will continue with the basic concept and Nuclear Physics 1. Today's lecture topic is atomic mass units. So let's proceed towards today's lecture. So the first questions normally that the student have in their minds is what is atomic mass unit and why we need the atomic mass unit. That is why we are not able to utilize the SI unit system while dealing with the quantities in the nuclear physics. So first of all, we have to deal with the answer first of all, we need to answer this basic question that why atomic mass units or what is the atomic mass unit. So you know that the atom is very small. So to deal with the very small quantities, just like atom, scientists have created the atomic mass unit. And the reason for this is to measure the mass of the subatomic particles. Subatomic particles, we mean the electron, protons, and the neutron. So in order to measure the smallest particle inside the atom, that is proton, neutrons, and electrons, the scientists have developed this smaller unit that we call atomic mass units. So this is the answer for a question that why we have developed or why we have the atomic mass unit. So it is because to measure the smallest size of the atoms or the smallest size particle inside the atoms, that is probably known as the proton, neutrons, and electrons. For this purpose, the scientists that have developed the atomic mass unit. So in this terminology, when we are asked that what is mean by the atomic mass, so the atomic mass is normally the number of proton and neutrons in a nucleus. So normally, the scientists ignore the mass of the electrons to be considered for the atomic mass of an element, and the reason behind is that the mass of the electrons is negligible as compared to the mass of the proton and neutron in a nucleus. So one atomic mass unit is a very small amount of the mass. So whenever we count for an atomic mass unit or NMU, so an AMU is basically 1/12 the mass of one atom of carbon 12, which has 6 protons and 6 neutron in its nucleus. So whenever someone asks you the exact figure or exact quantity about an AMU. So an AMU is about 1.66 and to 10 raised to power minus 27 kg or 1.66 and to 10 raised to power minus 24 grams. I mean, this is the exact amount we have in atomic mass units. So in atomic mass, values for the elements are usually represented by the letter A. I mean, it's English alphabet A. So are almost, never in integers. So the only exception is carbon, whose mass was used as a standard reference. So the mass of a carbon 12 atom is specified at exactly 12. So the mass of an atom of another element is the ratio of its mass to the mass of a carbon atoms. So even the mass of the protons, neutron, and electrons are ratios of their mass to carbons. These ratios are not integers, uh, and the reason for this is because atoms are made from various number of these particles. I mean, we say protons, neutrons, they are the well-known particle, and we say the atom, they are normally made from the combination of these particles. So it's unlikely that the mass of an atom other than carbon would add up to exactly a whole number. So you can have the atomic mass scale like the one you can see it here. I mean, it's the atomic scale. So the atomic mass scale was originally based on the hydrogens. So like here you can see that one hydrogen atom is equal to 1 AMU. I mean, that was originally based. So in this scales, if we have the oxygen atoms, so oxygen atom is equal to 16 AMU, and carbon atom is equal to 12 AMU. So now the scale is based on carbon 12. I mean, originally when the AMU scale was designed, so initially it was based on the hydrogens. So based on the hydrogens, we have the scale like this. So now the scale is being revised and carbon 12 is used. So based on the carbon 12s, we have carbon 12 atoms is equal to exactly equal to 12 AMU. So on this basis, we have one hydrogen atom, and that is equal to 1.00785252 AMU, and oxygen atoms, that is oxygen 16, that is equal to uh, 15.9949149 AMU. So here we remember, uh, here we have 1 AMU, and that is approximately equal to 1.6605 and to 10 raised to power minus 24 gram. I mean, the concept, I mean, that is the exact value for atomic mass unit. I mean, first, when the scientist given the concept of atomic mass unit, initially or originally it was based on the hydrogens. Later on, it was modified to carbon 12. So, I mean, this is the ratio that when it was based on the hydrogens, so the value was like this for the hydrogens, oxygen, and carbon 12. When it was revised, or it was based on the carbon 12, so then you can see it here again, the value they are being revised, and now the value are more precise. So carbon 12 is equal to exactly 12 mu. Hydrogen atoms, I mean, it's exactly equal to 1.078252 mu. And similarly, the oxygen atom, I mean, its AMU was also been revised. So here's, I mean, we have the exact value for the AMU and gram, which is equal to 1.6605 at 10 raised to power minus 24 grams. So the atomic mass, I mean, it's an AMU, in atomic mass unit, the atomic mass of the proton and the neutrons are approximately given here. You can see it here. So the proton, the mass of the protons, you know that is equal to 1.6726 into 10 raised to power minus 24 grams. That if we convert into AMU, so that is equal to 1.0073 mu. Similarly, the mass of the neutron is equal to 1.6749 and 10 raised to the power minus 24 grams, which if we convert into AMU, that will be equal to 1.0087 AMU. So what it mean? It means that the neutron is just a little heavier than the proton. I mean, here you can see the comparison. It's the mass of the protons, and this is the mass of the neutron. So if we compare these, so here you can see that a neutron is a bit heavier than that the mass of the protons. So the mass of a proton and neutron is about 1 mu. That is actually slightly larger. I mean, the mass of the neutron is slightly larger than that the mass of the proton. So here we have an example just to clarify more the concept of the atomic mass unit. And the example is if an atom has 3 protons, 4 neutrons, and 3 electrons, the atomic mass is about 7 mu. Why is 7 mu? Because you do not count the very small mass of the atom's electrons, which is 1 over 2000 AMU. So only at the number of proton and neutron, each has a mass of 1 AMU and the nucleus. I mean, that is the example or the clarification for the questions that why we ignore the electrons when we say or when we consider the mass of an atom. So we gave the reason for that, and the reason is that the mass of the electron is almost 1 over 2000 times the mass of the mass of the proton or the neutron. So being very small, we ignore the mass of the electron to be counted for the mass of the atom due to its smaller ratio. So here now we have the questions. I mean, this is the example that why electrons they are not being counted, why it's been ignored while we deal with the mass of the atom, the whole mass of the atom. So we given the reason that it's very small. How much small? Is almost 1 over 2000 times smaller than that the mass of the proton and mass of the neutron. So that's why we ignore while considering the whole mass of the atom. So now we have a questions, and the question is find the atomic mass of an atom that has 10 proton, 8 neutrons, and 10 electrons. So now how we can proceed to find the atomic mass of that particular atom? So the answer is, the answer is very simple, and it is 18 AMU. And how we can get this 18 AMU? We can simply get that by just adding the proton and the neutrons. And we ignore here, simply we ignore the 10 electrons. Why we ignore 10 electrons? Because you know that one electron is equal to 1 over 2000 times the mass, either the mass of the proton or a mass of a neutron. So here, just being very small, we ignore the mass of the 10 electron here. So by ignoring the electron, we can simply get the mass of the atom is equal to 18 AMU, and that we can simply get by adding the number of the protons and the number of the neutron. So we have add 10 protons and 8 neutrons. So just by adding 10 protons and 8 neutron, we get the atom mass equal to 18 AMU. That is very simple. So the difference in mass of the neutron and protons uh, can be understood if we assume that the neutron is merely a proton combined with an electron, forming a neutral particle slightly more massive than a proton alone. We have again here we have a questions that why neutrons is neutral, or why a neutron is heavier uh, than the uh, than the proton. So that can be very easily understood, that if we add a proton or we add an electrons to a proton, so its charge electrically it become neutrals, or if we say that if it's combined in this way, so it's make a neutral particle inside the nucleus that we can that we can adjust for the neutron, because mass electrically neutron is also neutral. But this is not the exact logic or 100% true logic. We can later on discuss that why the electron is electrically neutral, or why the charge of a neutron uh, is equal to 0. So the atomic mass of the electron is approximately equal to 9.1094 into 10 raised to power minus 28 grams, which if we convert to atomic mass unit, so that will be equal to 0.00055 AMU. So thus the electron has a much smaller mass than uh, either the proton or the neutron. And how much smaller it is? An electron is almost 1837 times smaller, or about 2000 times smaller than either the mass of a proton or the mass of a neutron. This is the comparative scale for the mass of an electrons. How much in electrons? This is the exact mass of the electron in grams, which is equal to the corresponding mass and the uh, atomic mass unit. So this mass if we compare with the individual mass of either a proton or neutron, so roughly we can say that uh, an electron is 2000 times smaller than either a protons or a neutrons. So that's why normally we ignore uh, in the atomic mass of an atoms. I mean, we ignore the number of electrons. We ignore the number of electrons when it comes for the atomic mass of an atom. So that's all we have for this lectures. I hope to see you soon in the next lecture. That will be lecture number 3, in which again we will proceed with the basic concept of the atom. And that particular lecture we will deal with the concept of the element. That what is an element and how we have different element in the periodic tables, and what are the concept relevant with the atom. So stay tuned with the lecture number 3, in which we will have discussions on the elements. So till then, bye bye.